Good morning, students. I, Vishal Srivastava, is here to teach you mathematics for class 10th. There are a total of 15 chapters in class 10th. In mathematics, our first unit is number system, and in this unit, our first chapter is real numbers. Today, we discuss about the first chapter, real numbers. In class 9th, we studied about real numbers, especially about irrational numbers. In this chapter, we continue our discussion on real numbers. Here, we will mainly study Euclid's division lemma and the fundamental theorem of arithmetic. Students, before starting this chapter, I am going to tell you some basic concepts of real numbers because that is very important for our study for real numbers. The first is rational number and the second is irrational number. What is a rational number? Its definition is those numbers which can be written in the form of p by q, where p and q are integers and q is not equal to 0. For example, 2 by 3, 4 by 5, 1, 2, 3, etc. Our second topic is irrational numbers. Irrational number, a number which can neither be expressed as a terminating decimal nor as a repeating decimal, is called an irrational number. Every non-terminating, non-recurring decimals are irrational numbers. Here are some examples. Students, two words came here. First one is terminating decimal and the second is repeating decimal. Now we will know what is terminating decimal. Terminating decimal, every fraction p by q can be expressed as a decimal if the decimal expression of p by q terminates, that is, comes to an end, means remainder becomes 0. Then the decimal so obtained is called a terminating decimal. For example, 1 by 4, 5 by 8 and 2 whole 3 by 5. When we divide 1 by 4, then the quotient is 0.25 and remainder is 0. Here remainder is 0, hence it is a terminating decimal. Thus, each of the numbers 1 by 4, 5 by 8 and 2 whole 3 by 5 can be expressed in the form of a terminating decimal. Our second heading is repeating or recurring decimals. Its another name is non-terminating decimal. Repeating decimals, a decimal in which a digit or a set of digits repeats periodically is called a repeating or a recurring decimal. For example, 2 by 3 and 3 by 11. Now come to our main heading, that is real numbers. Real numbers, a number whose square is non-negative, is called a real number. All rational and all irrational numbers form the collection of all real numbers. Every real number is either rational or irrational. Students, before teaching the Euclid's division algorithm, we need to know this: what is algorithm and what is lemma. An algorithm is a series of well-defined steps which provides a procedure for solving a particular type of problem. Now we will read what is lemma. A lemma is a proven statement which is used to prove another statement. Students, now we will read what is Euclid's division lemma. Euclid's division lemma states that given positive integers a and b, there exists a unique pair of integers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than b. Here we called a as dividend, b as divisor, q as quotient and r as remainder. So dividend is equal to divisor multiplied by quotient plus remainder. Here is an example. Students, Euclid's division lemma and algorithm are so closely interlinked. Euclid's division algorithm is a technique based on Euclid's division lemma used for finding the highest common factor of two given positive integers. Euclid's division algorithm, as the name suggests, has to do with divisibility of integers. It says any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r that is smaller than p. Many of you probably recognize this as the usual long division process. Now we will understand how to find the highest common factor with the help of Euclid's division lemma. According to this algorithm, the highest common factor of two positive integers a and b with a is greater than b can be obtained as follows. Step first, apply Euclid's division lemma to a and b. So we find the whole numbers q and r such that a is equal to bq plus r, where r is greater than or equal to 0 and less than b. Step second, if r is equal to 0, then the highest common factor of a and b is b, and if r is not equal to 0, apply the division lemma to b and r again. Step third, continue the division process till the remainder is 0. The divisor at the last stage will be the required SCF of a and b. Also, highest common factor of a and b is equal to highest common factor of b and r. Students, our today's topic is over, and all of you, as I said today, have to note this: everything should be written by you on your notebook, which is your homework. So thank you, students, and have a nice day.